calling the zero strategy. And this is a strategy for subtraction, and it's one that you're going to want to use whenever you see a zero in either the ones or the tens place of your top number, of your larger number that you have. I do not want you using the standard algorithm for when you see a zero up top, because you're going to have to do too much regrouping. It's just not as concrete as this idea I'm going to give you. Okay? When you have a zero in the ones place or in the tens place, it's just not the best strategy to use. When I look at this right here, 700 minus 487, basically, what do we know about subtraction? What is it? What am I finding right here when I'm subtracting these two numbers? If you think of a number line, it makes more sense. Parker? What am I finding?
You're subtracting to try to find the number to add.
Okay, I'm finding the number to add to this to get to this. So isn't that the distance between the two that I'm finding? I'm finding the distance or the difference between 487 all the way to 700. So, if I take 1 off of 700, I'm here, correct?
Mm-hmm.
So, if I start here and just still go back to 487, now I have changed that distance between the two numbers, haven't I? So I can't do that. But what if I take 1 off of this one? Now, I'm here, and even though I'm in two different spots, I've shifted each one to the left. Isn't my distance now the same?
Yeah.
So even though I've changed each of those numbers, I'm still finding that same distance between my two starting points. Do you see what I'm saying?
Yes.
So as long as we change both numbers, we essentially have the same problem that we had at the beginning. Because all I'm doing is finding the distance between the two. If I only change one of them, now my distance between the two has changed. But if I change both of them the same way, the distance between the two is the same. So, let me show you with the standard algorithm how messy this problem would be. If I have 0 ones chips in my ones place, I can't take 7 from them. So I have to unbundle a 10. Well, I don't have any 10s to unbundle. So now I have to go unbundle 100, and then I have to leave me with 1, and then now I have 10 10s. Now I have to unbundle 10s, and now I'm left with 9. Now I have to now I can give them all of my 1s. How many places are there to make an error there and forget the process? 3 different places, 3, almost 4. Because if you think, and just remembering why you have to do each thing, it just can get cumbersome and you can make a mistake pretty easily. But, so we can still get our answer, 213. So I'm going to shift this over a little bit, out of the way, and I want to show you the same problem in a much simpler form. Whoops, sorry. Same problem, correct?
Yes.
And we already talked about if I change both by subtracting 1. Why would I want to subtract 1 from 700 in this case? What happens when I subtract 1 from 700? Where am I going to be, Wink?
You're going to be at 699.
Now I'm at 699. What do you notice about 699? Mackenzie?
It fills up all the places.
It fills up all the places, but what about my 9s compared to zeros?
Those are the 10s and 1s that you could use.
Yeah, way easier to take from 9s than it is to take from zeros, correct? Am I ever going to have to unbundle when I have 9 on top?
No.
No. So if I now take 1 off of 487, Levi, where does that leave me?
486.
Look at my new problem. I don't have to unbundle anything because I know I have plenty of chips in each column. So 9 minus 6 is?
3.
3. 9 minus 8?
1.
6 minus 4?
2.
2. Same answer. A lot easier. You're going to be so much more accurate. You're not going to panic on a test if you're like, I don't remember if I'm doing this right. I can't remember. I feel like I might be, but I don't remember. If I missed a step, you don't have to worry about it. Because you know your basic facts, hopefully. Some of you still make mistakes on those. And you know that your answer, you're going to be more confident in your answer when you do it this way. All right? We'll do another one in just a second. You can stop that first.